So in this next problem, we are asked to determine the cell potential, standard cell potential, and the standard gives free energy for the reaction to bromide reacting with chlorine to produce bromine and 2-fluoride, given the following reduction potential. So the reduction of chlorine to fluoride is potential 2.87. The reduction of bromine to form 2-bromide, which has a cell potential of 1.06. So the first thing that we're going to do is determine which one happened in the cathode and which one happened in the anode. And we can do it from the reaction here. So we can look at the oxidation number here. Okay, so this is what? -1, 0, 0, -1. So in doing so, you could see here that your bromide from -1, it becomes what we call more positive. Okay, it becomes what we call 0. So we could say that's the one that undergo oxidation, or that's the one that happens in the anode. Okay, now on the other hand, for the cathode, so it's from 0, it becomes what we call more negative. So this one, the one that is reduced. So we could say, assign out that this is the one that happens in the cathode. So E cell is equals to E cathode minus E anode. And look at the value that is given. So this is about 2.87 minus 1.06. So this is equals to 1.81 volt. And we can now answer the question, is the reaction spontaneous? And we could say it is spontaneous because you have a positive cell potential. So you have here a galvanic cell. Now the next question is standard free energy. So you have it times N times Faraday constant times the standard cell potential. So based on this reaction, okay, 2 negative here, 2 times -1 going to 0. So that means there's 2 moles of electron that is involved. And based on the Faraday constant, okay, there's always what? 96,500 coulombs per mole of the electron. And the voltage that we have here, the cell potential, so that is equals to 1.81. So volt is really joules over coulomb. So if we're going to look at the unit that we can cancel out, the one that is left here, you have a -1. So if you're going to do the calculation, so that's around this value, which we can round up to be around 349 kilojoules. So that's the answer to this question.